Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Now we discuss preparation of oxalic acid from molasses. Key concepts. Key concepts of this lecture including use of molasses, composition of wheat molasses, molasses and its properties, types of molasses, making of molasses, preparation of oxalic acid, preparation of oxalic acid by molasses using nitric acid, laboratory preparation of oxalic acid, comparative study from different sources. Process descriptions include CSTR, continuous stir tank reactor, separation process, conversion of NO nitric oxide into hydrogen nitrate or nitric acid, fluidized bed reactor, absorber, flow sheet diagram, and last one we discuss conclusion. Uses of molasses. Molasses is commonly used with yeast and water in the fermentation process of making rum. It is also used in creating some other alcoholic drinks such as stout and dark ale. So what is rum? To make rum, dissolve sugar and molasses in hot water. Let it cool and added hydrated yeast. Let that mixture ferment for a couple of days before we chill it to knock the yeast to the bottom of the bucket. Then distill the rum by running a siphon from the mash to a collection tank. Some tobacco companies add it to their product for smoking through a certain type of pipe popular in the Middle East countries. Some anglers use molasses as a ground bait, also called chum or burley. This is designed to attract fish to the area that an angler is fishing. Angling is a method of fishing by means of an angle, that is a fish hook. Ground bait is a fishing boat that is either cast or balled into the water in order to attract fish to the fishing area. Chumming is used in American English, is the practice of luring various animals, usually fish, by throwing chum into the water. In Australia and New Zealand, chum is referred to a burley. Ground bait is used in the European term. It can also be mixed with water and used to remove dust. It is also used in some horticultural settings to promote microbe activity in the soil. Molasses contains trace amounts of important vitamins and minerals. A certain type of molasses called black strap molasses has been sold as a health supplement for many years. Molasses is also added to some cattle feed to add essential vitamins and minerals. Black strap molasses is a byproduct of sugar cane's refining process. Molasses is the dark, sweet, syrupy, concentrated juice byproduct made during the extraction of sugars from sugarcane and sugar beets. Molasses is a viscous byproduct of the refining of sugarcane grapes or sugar beets into the sugar. The word molasses comes from the Portuguese milico, ultimately derived from mel, the Latin word for honey. Types of molasses. Molasses are of various types based on plant material from which it is produced. Different types of molasses produced based on various raw materials are such as cane molasses from sugar cane, beet molasses from sugar beet, grape molasses from grapes, etc. Now, molasses and its properties. Molasses and other agricultural waste have gained increasing importance as raw materials. These materials are not only inexpensive, which means not expensive, cheap, but must be further processed in any case due to environmental reasons. Molasses contains as a production residue of sugar refinement many nitrogen containing compounds which are however for the most part removed during nitric acid oxidation. This explains the difficulties encountered with excessive foam forming during the production that must be overcome. Now continuing the molasses and its properties. If starch products are used as raw materials, they must be hydrolyzed to glucose in an extra batch-wise step prior to the actual oxidation. This is carried out by boiling the starch suspension in the presence of oxalic acid or sulfuric acid for about 6 hours. The oxidation of the resulting glucose and the following steps are then essentially continuous operations. Molasses are of different kinds based on their raw materials. For example, sulfured molasses, unsulfured molasses. Sulfured molasses is made from young sugar cane. Sulfur dioxide, which acts as a preservative, is added during the sugar extraction process. Unsulfured molasses is made from mature sugar cane, which does not require such treatment as described in above. Making of molasses. To make molasses, the cane of a sugar plant is harvested and stripped of its leaves. Its juice is extracted usually by crushing or mashing. The juice is boiled to concentrate it, which promotes the crystallization of the sugar. The result of this first boiling and of the sugar crystal is first molasses, which has the highest sugar content because comparatively little sugar has been extracted from the source. Second molasses is created from a second boiling and sugar extraction and has a slight bitter taste. The third boiling of the sugar syrup yields black strip molasses known for its robust flavor. The majority of source from the original juice has been crystallized and removed. The food energy content of black strip molasses is still mostly from the small remaining sugar content. As you know, black strip molasses is a byproduct of sugar cane's refining process. However, unlike refined sugars, it contains trace amounts of vitamins and significant amounts of several minerals. Now continuing the making of molasses, black stripe molasses is the source of calcium, magnesium, potassium and iron. 1 tablespoon provides up to 20% of the daily value of each of those nutrients. Black stripe has long been sold as a health supplement. It is also used in the manufacturing of ethyl alcohol for industry and as an ingredient in cattle feed. Molasses made from sugar beet is different from sugarcane molasses. Only the syrup left from the final crystallization stage is called molasses. The intermediate syrups are referred to as high green and low green, and these are recycled within the crystallization plant to maximize extraction. Beet molasses is about 50% sugar by dry weight, predominantly sucrose, but also contains significant amount of glucose and fructose. Beet molasses is limited in biotin, vitamin H and B7 for cell growth. Hence, it may need to be supplemented with biotin source. The non-sugar content includes many salts such as calcium, potassium, oxalate and chloride. It also contains the compounds betaine and the trisaccharide raffinose. These are either as a result of concentration from the original plant material or as a result of chemicals used in the processing and make it unpalatable to humans. Hence, it is mainly used as an additive to animal feed called molasses sugar beet feed or as a fermentation feedstock. Making of molasses. To make molasses, the cane of a sugar plant is harvested and stripped of its leaves. Its juice is extracted usually by crushing or mashing. The juice is boiled to concentrate it, which promotes the crystallization of the sugar. The result of this first boiling and of the sugar crystal is first molasses, which has the highest sugar content because comparatively little. Now, preparation of oxalic acid. Preparation of oxalic acid from molasses is the most effective and cheapest way. Process involved for the production of oxalic acid from molasses are by using nitric acid, by fermentation process, by using aspergillus niger, etc. Preparation of oxalic acid by molasses using nitric acid. First of all, laboratory preparation. The sugar beet molasses used in the experimental contain 48.1% sucrose, 3.2% inward sugar and 19.4% water. The chemical employed for the preparation of oxalic acid by molasses using nitric acid are 65% of hydrogen nitrate and 93% of sulfuric acid. Besides this, a catalyst is also required as catalyst 7.5% of vanadium pentoxide on porous silica gel supported was used. Now we discuss this process in detail, which are the preparation of oxalic acid by molasses using nitric acid. 3 reactors are used in this process. The details of the experimental setup are given in figure 2. Reactor 1 is used to produce oxalic acid from sugar beet molasses with mixed nitric acid and sulfuric acid in the optimum conditions of it. It is simultaneously utilized as a source of nitrogen oxides NO needed as a reactant in the second reactor and third reactor. The non-sugar content includes many salts such as calcium, potassium, oxalate and fluoride. It also contains the compounds betaine and the trisaccharide terpenes. These are either as a result of concentration from the original plant material or as a result of chemicals used in the processing and make it unpalatable to humans. Hence, it is mixed acid is added to the first reactor at a rate of 6 ml per minute through a funnel fitted to the neck of the flask. The nitric acid and sulfuric acid mixture is added from the dropping funnel as a thin stream. Now, thereby the reaction in the reactor is started. The reaction temperature is controlled by adjusting the heating or water cooling through the water bath. The oxides of nitrogen evolving from the reaction in the reactor are carried by airflow to the second and third reactor. These oxides are meant to act as exciders in the second and third reactors that contain enough hydrogen sulfate but no nitric acid. In order to see how the conditions in the second reactor affected the oxalic acid yield, temperature, quantity of sulfuric acid, catalyst, additional water and total airflow rate for the two reactors are chosen as parameters. Second molasses is created from a second boiling and sugar extraction and has a slight bitter taste. The third boiling of the sugar syrup yields black strip molasses known for its robust flavor. The majority of source from the original juice has been crystallized and removed. The food energy content of black strip molasses is still mostly from the small remaining sugar content. As you know, based on these observations, the delay for the start of the reaction in the third reactor is assumed to be 61 minutes, and this is used in the kinetic studies. The reaction is assumed to be completed when the color of the exhaust gases turned pale yellow. The reaction mixture is cooled to about 0 centigrade and oxalic acid crystals are separated by vacuum filtration. Approximately 80% of the filtrate is evaporated gradually in a dish at about 45 centigrade, and then it was cooled to -5 degrees Celsius. The needle shaped crystals of oxalic acid are separated again by vacuum filtration, and crystals are combined with the previous lot. Now, continuing the preparation of oxalic acid by molasses using nitric acid, for recrystallization, the crude product is dissolved in hot water filtered and cooled to 0 degree Celsius. Then pure crystals are separated and the residual filtrate is again evaporated in a dish at about 45 degrees centigrade. By the same manner, the saturated solution is cooled to 0 degrees centigrade and filtered. The crystals are dried at about 60 degrees Celsius and where the product is finally checked by determining the melting point, elemental composition and percent purity. Comparative study from different sources. All kinds of molasses are used as a raw material for both the process such as laboratory methods and industrial method. For optimization, we have to select the best process in terms of cost and efficiency of the products. Here is the comparison study. First of all, when we use nitric acid, the time required to complete this process is 2 to 3 hours and we get the yield of 75% of oxalic acid. Similarly, by using potassium ferrocyanide, the time required for this process is 3 to 4 hours and we get the yield of 52% of oxalic acid. The last process, by using aspergillus niger, the time to complete this process is 7 to 8 hours and we get the yield of 61%. So in this comparison study, the most efficient method for the production of oxalic acid is by using nitric acid and the yield of percentage yield is 75%. Second molasses is created from a second boiling and sugar extraction and has a slight bitter taste. The third boiling of the sugar syrup yields black strip molasses known for its robust flavor. The majority of source from the original juice has been crystallized and removed. The food energy content of black strip molasses is still mostly from the small remaining sugar content. As you know, black strip molasses is a byproduct of sugar cane refining process. However, unlike refined sugars, it contains trace amounts of vitamins and significant amounts of several. Process description: continuous stirred tank reactor, abbreviation as CSTR, R1 as shown in the flow sheet in the next slides. Initially, molasses is preheated and its temperature increased from 37 degrees Celsius to 65.5 degrees Celsius. After that, it is fed into continuous stirred tank reactor. Simultaneously, nitric acid is also fed into the continuous stirred tank reactor CSTR with vanadium pentoxide. As you know, in this reaction, vanadium pentoxide is used as a catalyst. Now this mixture is mixed thoroughly and is allowed to react for 2 to 3 hours. After 2 to 3 hours, oxalic acid and nitrogen oxide formed. Oxalic acid along with unreacted molasses, unreacted nitric acid and vanadium pentoxide comes out from bottom section of continuous stirred tank reactor CSTR and undergo further separation process. Separation process. During this process, vanadium pentoxide, which are used as a catalyst, first get separated out with the help of filter. Oxalic acid and mother liquor, unreactive nitric acid and molasses is separated into two-stage processes. At first stage, solution that has been filtered is fed into crystallizer, in which oxalic acid crystal along with the mother liquor comes out, and further these are separated with the help of centrifuge. Mixed acid is added to the fast reactor at a rate of 6 ml per minute through a funnel fitted to the neck of the flask. The nitric acid and sulfuric acid mixture is added from the dropping funnel as a thin stream. Now, thereby the reaction in the reactor is started. Conversion of nitric oxide into hydrogen nitrate. Nitrogen oxide gas, which comes out from the top of the continuous stirred tank reactor CSTR, cannot be discharged directly to atmosphere, as it can cause air pollution. A continuous stirred tank reactor CSTR is a batch reactor equipped with an impeller or other mixing devices to provide efficient mixing. So this gas sent to compressor T to increase pressure, and then to steam heater S to increase temperature. Fluidized bed reactor F. After that, gas sent into fluidized bed reactor F in the presence of aluminum oxide Al2O3 catalyst. Nitrogen dioxide is formed by the combination of nitric oxide with oxygen molecules. After this reaction, aluminum oxide gets separated by cyclone separator CY. As you can see, the reaction nitric oxide combined with oxygen to produce nitrogen dioxide. A fluidized bed reactor F is a type of reactor device that can be used to carry out a variety of multi-phase chemical reactions. Similarly, cyclonic separation CY is a method of removing particles from an air, gas or liquid stream without the use of filters through vortex separation. Absorber R2 as shown in the flow sheet diagram on the slide number 37. In an absorber, nitrogen dioxide gas is allowed to react with water separate inside the absorber R2 to produce nitric acid and nitrogen oxide gas. You can see in the chemical reaction, nitrogen dioxide reacts with water molecules to produce nitric acid and nitric oxide. Nitric acid 20% of butane, which is less concentrated than the nitric acid 95%, which is used as a feed, can further be used in other industrial processes. Nitrogen oxide, which is also named as nitric oxide, gas can be recycled back to stream, leading to fluidized bed reactor F. Here you can see the flow sheet diagram of preparation of oxalic acid from molasses using nitric acid. In this diagram, We can start from the left side. At the upper part, you can see a cylinder or tank or reactor. R1 is shown in this reactor, which is a CSTR. CSTR means continuous sterile tank reactor. After this, you can see a T, capital T, which is a compressor. Then you can see a circle with an arrow. This is called stream heater. Then a cylinder F. You can see in also cylinder R2. Between F and R2, you can see at the above CY. CY means cyclone separator. R2 means absorber. Now you can see at the lower side N1, C1, N2 and C2 boxes, where N1 and N2 are crystallizers, C1 and C2 are centrifuge, and last one you can see capital D box, which is a tunnel dryer. Oxalic acid is obtained from tunnel dryer crystals, almost 95% pure. Now finally, conclusions. This process leads to considerable improvement in yield of oxalic acid in single step. In this case, production of oxalic acid is as high as 75%. This process has an advantage of producing nitric acid and nitrogen oxide gas, which can be used in other industrial processes or upon treatment of this byproduct. You can see in the reaction nitrogen dioxide react with water to synthesize hydrogen nitrate with nitrogen oxide or nitric oxide. It can also be used in the same plant. Purity of oxalic acid in this process is 98%, which is the best available in the market. Dear students, thank you very much.